In this lecture, we'll continue with the lateral equations, and especially the topic is banked flight with steady side slip, and pay attention to the word steady side slip. And this maneuver is equivalent to the approach on a crosswind, and which means, for example, the aircraft is landing and on a crosswind. And again, I want to highlight the word steady side slip. Okay, so let's continue. So when an aircraft is on the steady side slip, what happens is, in order to maintain a steady side slip, first of all, the aircraft need to have aileron deflection. So the left aileron will deflect downwards, and the right aileron will deflect upwards. In this case, the aircraft will have right wing down. Is that right? Why? Ask yourself. And okay, so let's see the force acting on the aircraft. So we have lift, and the lift is tilted with an angle of phi. That's a bank angle, and with respect to the vertical line. And also there is a gravity mg. And apparently this won't balance the aircraft. The aircraft is not in equilibrium. In order to maintain a steady side slip, there will be a side force from the fin. So that's from y beta times beta. That's because of the side slip angle. So now let's move to the top view. Okay, so for example, now and the aircraft is in a steady side slip. We have a steady side slip velocity v, and it's indicated by the blue arrow. And now, since it's in a positive side slip, the wind is blowing from the top right. And okay, so then now we move to the vertical tail, and it's in a positive angle attack. So in that case, there will be a side force, y beta times beta. That's what we've indicated in the rear view. Is that right? Okay, because there is a side force produced, and this side force is pointing towards the left, and then accordingly, this force will produce a yawing moment, positive yawing moment, and then the aircraft will tend to align with the wind. So there is no side slip. In order to maintain the side slip, there will be another force to balance, to alleviate this yawing moment. And in that case, we need to have a rotor deflection. The rotor would be deflected towards the left. So delta R, and that's a deflection angle. And in that case, we'll have a side force. That's indicated by the blue arrow. Okay, so in a steady side slip, the net force and the moment will be 0 in total. Okay, so now let's study the equilibrium equations. We've understood the scenario, aircraft scenario. Okay, we have y force, that's in vertical direction. And then we have rolling moment. Rolling moment has 3 contributions. One is from the side slip angle, the other is from the aileron deflection, the third is from the rotor deflection. So, and similarly, we have yawing moment, and it has 3 contributions. Okay, and so if we look at the first equation, y force equation separately, if we know y beta, which is side force due to side slip angle, and then we can calculate beta angle, side slip angle. Because an aircraft is gnawing, then y beta is gnawing. Okay, we know the beta. And now let's look at the rolling moment equation and yawing moment equation, the second and third equations. And since beta is gnawing, and we can move the L beta times beta and beta times beta towards the right hand side of the equation, and then we combine these 2 equations and write down in the matrix form. So we have the equation here, and then if we indicate the coefficient equation as A, the result as B, and then we can simply calculate delta A and delta R as minus A to the power of minus 1b beta. Okay, so this is a typical way we calculate the aileron deflection and rotor deflection. And you may wonder, because we do this, it's a bit complicated. Yes, there's a way to do the simplification. So we can assume L delta R, which means the rolling moment change due to the aileron deflection, or due to the rotor deflection is nearly zero, negligible. The same, the yawing moment change due to the aileron deflection change is negligible. And does that make sense? Because the rotor deflection, primary function of rotor deflection is to produce a yawing moment. So the rolling moment can be neglected in some circumstances. And we call these the secondary effects. And the secondary effects are negligible on a current simplification. Okay, so in that case, the two equations, L and N equation, can be simplified. And then we can calculate delta A and delta R, the aileron deflection angle and the rotor deflection angle separately, explicitly. So that's what we are going we have for the aircraft on a steady side slip or approach on the crosswind.